Okay. Now today, something changed. There we go. Okay. What looks different, guys? Tell me.
It equals something now?
Yeah. Now today it says equals 0. Okay, before we were just saying, hey, factor this. And you're like, okay, I'm going to factor. But of course I need to add on, and there's a reason I wanted you to learn how to factor. Okay, so today it's saying it would like to know what value of x do I substitute in here to make all of this go to 0. So I get 0 equals 0. That's basically what it's asking. It's kind of saying, hey, here's a table of values, or, and when I put in x, I want to get out, in this case, I just want to get out 0. So they want to know what value of x can you put in there and get out a 0. Okay, that's what they're asking. So the way you're going to find that out is we're going to solve this by factoring. I'll do my little sidebar first of all, and I'm going to ask someone to respond to me. I've got a number I'll just call it A, and another number B. A times B, and I'm telling you it equals 0. What can you tell me about A or about B? What has to be true about one of those two variables?
They have to both be positive or both be negative.
Okay, give me more. Someone add on to that.
One of them has to be 0.
Thank you. Okay, one of them has to be 0. I'm multiplying two numbers together and it says equal 0. Either A is 0 or B is 0, or both of them are 0. They could both be 0, but one of them has to be 0. Okay, so see how this says equal 0? Well, it'd be nice if I knew what two things multiplied together to give me this, and that's why we learned how to factor these. If I could write this as two things multiplied together, a parenthesis times another parenthesis, and say equal 0, I can figure out what values will actually make this expression equal 0. So we're going to go ahead and factor this just like we have already. Nothing's going to change today with the factoring. Nothing ever will change. You've learned how to factor. We're good to go. 42. This is a minus down here. And I know these have to be the same sign because two numbers multiplied together to give me a positive. I either have both positives or both negatives. The reason these are both negative is because of this. Okay, 42. We've got 42 times 1, 2 times 21, 3 times 14, 4. Doesn't go in there. 5, 6 times, I like 7 and 6. Today, you're going to have a challenge question to leave class a little bit early and start on your homework. And I promise you, if you can't figure out these two numbers, it's because you haven't figured out a pair of numbers that multiply to give you this third number. I like 7 and 6 for this. -7, -6. So you're going to write it x minus 7, x minus 6. Okay, so now I have something times something. It's kind of like saying, hey, here's A and here's B. Okay, they're multiplying each other. Well, either this is equal to 0, this A, or this is equal to 0. So you can solve both of these. You can say x minus 7, either this equals 0, or x minus 6 equals 0. One of them has to be a 0 for this to be a true statement. I will also clue you in. We're actually going to get two answers today. The thing that clues me in, because I've done math for a long time, is when I see x squared, because it says x squared, I'm pretty much 90% of the time going to get two answers. Kind of like absolute value. When we were solving absolute value equations, we had the positive and the negative side. Well, x squared, we're going to have used, not all the time, but most of the time you have two answers. So I'm looking for the two values that I can stick in there. So, and here they are. All I have to do is solve these two. Add 7 to both sides, and I get x can either be 7, or, let's add 6 here, x could be 6. Okay, so I got my two answers. And the way I write this is 6, 7. It's not an ordered pair. Notice I put braces. I'm just saying x can either be 6 or can be 7. Okay? Now, I'm going to show you why this works and that it actually does. Okay, but what this means is if I put a 6 in to the original equation, it's going to get 0 equals 0. Or if I put a 7 in, it's also going to get 0 equals 0, which means I have 2 points on the graph. I have 6, 0. I have 7, 0. So think about on a graph, where would this be? 1, 2, 3, 4, 5, 6, 7. There's 7, 0. Here's 6, 0. Oh, they're right next to each other. It tells me this parabola is going to go through those 2 points. I'm not sure what the vertex is, but I guarantee you these are called the zeros of this parabola. It's where they cross the x-axis. Technically, they're the x-intercepts. Not the y-intercept, the x-intercept. Y-intercept, remember, hits here. Okay, x-intercept is where it hits the x-axis. They call them zeros. They call them solutions. They call them roots. But I'm going to go ahead and check my work. So my original problem was x squared minus 13x plus 42 equals 0. I'm going to plug in 7 for x. Everywhere you see x, it's got to go. So 7 squared minus 13 times 7 plus 42 equals 0. 7 squared is 49. 7 times 13, I don't know. I get 91 plus 42. I'm going to put all my positive numbers in a pile. Positive 49, positive 42 is positive 91. Minus 91. I get 0 equals 0. It checks out, so this is a good answer. I'm also going to check now the 6. I'm going to plug it into the same original equation to see if it actually makes a true statement. And it should if we've done right. That's why I like algebra. You could, once you find the answer, you get to plug it in to see if you actually did it right. 6 squared minus 13 times 6 plus 42 equals 0. 6 squared is 36. 13 times 6. 70, 78, 60, yep, 78. Okay, I'm going to add all my positives in one pile. So 36 and 40, 56, I get 78. Minus 78 equals 0 or 0 equals 0. It checks out. So I found 2 answers.